Hello students, welcome to our video lecture on module 9A, changing speeds and feeds in a lathe. This is a part of the course Machine Tools and Machining ME 30604. This lecture is taught by four teachers, me Nilanjan Das Chakladar, Professor Sankha Deb, Professor Soumitra and Professor Partha Pratim Bandyopadhyay of Mechanical Engineering Department at IIT Kharagpur. Before we discuss the method of changing speeds and speeds in a lathe, let us recall the working principle of the speed gearbox, feed gearbox, meander, and the thread cutting mechanisms in brief. Speed gearbox involving the sliding cluster or clutches helps to change the speed and provide suitable spindle torque relevant to that speed. The feed gearbox, with the help of a Norton and meander drive arrangement, helps to feed the tool post in the longitudinal or the transverse direction as required for the machining operation. In the figure, we see meander drive is represented by M, which helps to meander or direct the power from the motor through a lead screw to provide the feed motion. The word meander suggests that the power of the motor is not directly fed to the feed motion. Next, a thread is cut on a lathe with the help of a meander drive, the lead screw, and carefully engaging the half nut for auto feed. Different variants of pitch can be cut, which we will discuss in the module 9C. Now coming to cluster gears, let us look at the figure. So in the figure, we see there is an input shaft, there is an output shaft. The input shaft has a rotation Ni and the output shaft has a rotation No. Now there are a set of gears and also there is a transition shaft. Now let us assume that all the gears are numbered, and if gear A meshes together, these two gear A's, they mesh together, so that means the torque is now transmitted from the input shaft to the transition shaft. However, it will depend on this set of sliding clusters whether this transition, how this transition will be again transmitted to the output shaft. So let's say A meshed with A and now C meshes with C. That means on the right table, if we see, if the input is AA and the transition is also the C gears are meshing, we get an output AACC. So we can accordingly find out the gear transmission ratio. So there could be other 5 possible combinations where how this cluster gear can combine or can mesh. Now, an alternative arrangement to the cluster gear are the clutches. So again, let us look into the figure. So this is input shaft with the same rotation Ni. This is output shaft with the rotation No. And there are two set of clutches, C1 and C2. Now here it is to be noted that whenever we use the word clutch, it reminds us of our driving. Why? Because while driving, we press the clutch and change the gear. What does that mean? Does it engage the clutch or disengage the clutch? It actually disengages the clutch so that we can shift the gear. Similarly, here we bring the clutch and let's say we engage it with the gear set A. That means we are engaging it to the left. So if we look into the table C1L, it means C1 is engaged to the left. So the A gear is now active, the set of A gear is now active, and now it will depend how C2 is engaged. So whether C2 is engaged to the left or C2 is engaged to the right. If C2 is engaged to the left, we get the first combination of gear sets, which is AB. It is also to be noted that for the same module, the sum of number of teeth in a pair of meshed gears is fixed. So coming back to the table here, so this is one combination. There could be other three combinations how C1 and C2 are engaged to the left or to the right. Thank you for listening to this module. Hope you enjoyed it. We conclude this module here.